Hey guys, welcome here. Today's lesson is going to be to watch the video that you're watching right now, and then to complete as much of the assignment as you can, and then we'll talk about the assignment next class and keep going from there. So watch this video and then try out what we're learning on the assignment. So even if you had trouble in the first part of the assignment, this will be helpful. Okay, so this is at the bottom of your notes. So I want you to pull out your notes. Mine isn't filled out, but these are the notes that we did with Taylor Swift, right? The classifying chemical reactions, and at the end we didn't finish the notes. We ran out of time, and that's okay because we didn't quite get this far. I want to work on it now. Can we determine the type of reaction just by knowing what's up here? Now this is called the product. No, sorry, I always get it mixed up. These are called the reactants. Okay, the reactants, because they are what are reacting, and then where did it go? Then a chemical reaction happens. This is a chemical reaction, and then all of a sudden we get some products. And so we're trying to determine what the products are. This is bad news. Everything I write keeps disappearing. I hope this doesn't last. All right, we got calcium and oxygen. What kind of reaction is going to happen? This has to be our first step. Well, what we see is we have a single element and another single element. It's a double pair of oxygen because it's Hofbrinkel, but essentially it's two single elements. Okay, I found something. So you have calcium and oxygen that are going to bond. So what is this? This is going to be synthesis. How do we know it's synthesis? Well, because we got two singles coming together. And so if we look back at our notes, there's just no other option. These are not doing well today. Okay, you'll have to scroll up to the top and look at synthesis, and you'll realize, yeah, this must be synthesis. We got a single, and we got another single. This is synthesis. And so then what is going to be the product of the reaction? Well, the product is going to be calcium and oxygen together, so calcium oxide. Now, is this how it will bond? What kind of bond is this? It's an ionic bond. And so if you look at your periodic table, you'll quickly see calcium has a charge of 2, oxygen has a charge of 2, this is plus, this is minus, and so it would be a one-to-one bond, so it would in fact be calcium oxide. Done. Awesome. Number 2, what kind of bond is this going to be? Well, it's potassium hydroxide and hydrogen sulfate, right? And so it's two pairs, so this is double displacement. There's no really other option here. Yikes, it's a lot of writing. Double displacement, and so what's going to be the products of this? It's going to be potassium sulfate, SO4, brackets, and mixed with hydrogen hydroxide, HOH. That's really just water, right? But HOH is fine. Potassium has a charge of 1 plus, and sulfate has a charge of 2 minus. So it's 1 plus, 2 minus. So this is with the sulfate, but whatever. Which means we're going to need 2 potassiums and 1 sulfate. There we go. And HOH, we know that H2O is perfect. That's how it's going to bond. Then we're done. We did this one. Okay. Let's think about this next one. This is going to be CH4 and O2. Now, at first glance, you would think, oh, this is single displacement, except that this here is a hydrocarbon. So this is going to be hydrocarbon combustion. And so if this is hydrocarbon combustion, then we know what the products are going to be. It's going to be H2O and CO2. How come? Look up at the notes. This is always the product of a hydrocarbon combustion reaction. And hydrocarbon combustion are always carbon and O2. Carbon hydroxide, carbon and hydrogen. This is called a hydrocarbon, and O2, and it always produces water and CO2. Okay, next one. We've got HGO, this is one compound. The only kind of reaction that can happen is decomposition. All right, and so what's going to be the products of this reaction? Well, all that's left is Hg and O. We have to think a little bit about Hofbrinkel. Hg is not part of Hofbrinkel, but O is, and so it would be O2. And then we're done. And last one, what are the options here? We've got a single and we've got a pair. We've got aluminum and we've got lead nitrate. And so what we're going to get as the products, this is single displacement. This is the type of reaction. That's the only thing it could be, because it's not a hydrocarbon. We've got a single and a double, so they're going to swap partners. Single displacement. And the first thing I want to check is aluminum is a metal, so it is going to swap with the metal. And so what we're going to get is we're going to get Pb by itself, lead, not part of Hofbrinkel, so no 2, and it's going to bond with, and the other one is going to be, well, aluminum replaced Pb, so AlNO3. And we do have to think about numbers. Aluminum has a 3+ charge, and nitrate has a 1- charge, and so now we're going to have 3 nitrates. Just swap and drop, right? And now that's it. Okay, so we've done all of these types of reactions. We can predict the type: synthesis, double displacement, hydrocarbon combustion, decomposition, and single displacement. Okay, how do we know? Is we look at the beginning and which one matches up. Wow, that's not what I wanted to do. Sorry, which one matches up with what we saw up here in the notes? Okay, here's hydrocarbon and oxygen, CO2 and H2O, hydrocarbon combustion. There's double displacement. Are there a pair and another pair? That's hydrocarbon combustion. We don't even need to see this side to know. Sorry, I said hydrocarbon combustion. This is double displacement. We don't even need to see this side to know that. Here we have one and then a pair. We don't even need to see this side to know this is going to be single displacement. And this page is not loading. But we've got synthesis is when we've got 2 individuals. They're going to come together. When we've got 1 individual, it's going to be decomposition, and they're going to spread apart. So hopefully this helps going through this video. We can answer these questions. Describe the difference between single displacement and double displacement reactions. What is the difference in single displacement reactions? What do we see there? There is a single element before and after the reaction. In double displacement, that's so annoying. Oh, this is brutal. In double displacement reactions, both reactants, I can't stop writing, have compounds. It should be are compounds. Okay? And compounds means that there's more than one atom. Okay? More than one element in the compound. How do you compare synthesis and decomposition reactions? They are the same, but flipped around. Hopefully you can see that. What are the products of a hydrocarbon combustion reaction? Always CO2 and H2O. What do the arrows in a reaction represent? That a reaction took place. This is insanity. All right. Identify the products and reactants of the following reaction. It starts off with the reactants. There are what will reactants. And now we've got, this must be the products. What is produced? My tendency is always to mix these up, but that's how it is. Why does it make sense that we would see the exact same elements as the products as the reactants? Okay, notice here we got sodium and chlorine, and here we got sodium and chlorine after the reaction. Why does it make sense? Because elements can't be created or destroyed. Their composition in bonds is all that can change. This is always true except when there's radioactive material that is breaking down. But generally, this is always true. And we'll follow that. Okay, that was a gong show. Look at all the notes we took. It's brutal. Did this work up here? It's just messy. Lost it. See, that's why I didn't like, this is brutal. Anyways, okay, your homework now. We've done the notes. Hopefully that worked. And your homework now is going to be to try the assignment. We've done some examples. Hopefully that helped. What you should be doing is looking back to all of these examples that we did in the notes and what does each one look like. And then the second stage is to start to try to predict the products like we did today. All right? Email me if you have questions, but I'll see you on next class.